behind on that. We have two triangles, and I was reminded just recently of making sure you pay attention to the orientation of these. So I'm going to go ahead and put some of the markings here because that does matter. You got to pay really close attention to how they might be flipped or turned or however. I made that mistake on one of these recently. So yeah, those are that person's there. This one's mine. So let me color code it just to help myself out. And then this. So what are these indicators for, first of all? What do they tell us?
The right.
Not right angles. Could be, but don't tell us that either. I use the same colors to show that those two angles are equal. The orange angles are equal. The pink angles are equal. The yellow angles are equal. Therefore, all the angles are corresponding in each triangle. The significance of that is that the triangles are similar because of that. If you don't have that information and you don't have a statement that says the triangles are similar, you can't write a proportion to solve things. You might have to do something else. If there is anything else you can do. So what we'll begin doing now is filling in the information that we have from the problem, and then this was P and this is 2. And they're only asking about those. So let's make sure we recognize that 21/24 is the side of the little triangle that corresponds to the 2 in this triangle. Here's where color helps me out, and it might help you. You might not need it. It's between yellow and orange. So even if they gave me this side, I would need to make sure that I used the side between yellow and orange to correspond with the 21/24. And likewise, 7/12 and P, those are going to correspond. So again, then we can just begin to write a proportion. A proportion is just one ratio set equal to another ratio for the purpose of solving for one unknown. So I can go little to big with the corresponding here, so that's just a 2. Then I can go little to big here. I actually have to go in the same order on the right side ratio. If I mix up the order, then the problem's going to be wrong. Okay? For proportions, we've learned to cross multiply, so we'll do that. 21/24, so we can just slap the variable into the numerator. That's consistent when you multiply fractions, the top times the top. The whole number becomes the numerator, essentially. And then we'll set that equal to 2 times 7/12. Well, that would be 14/12. Again, where did that come from? 2 is the same as 2 over 1. 2 times 7 over 1 times 12. Now it looks almost the same again. So that's kind of how these problems have worked. You cross multiply once, you get a simpler one, you cross multiply again. So 14 times 24, let's see, 280, but 336. I don't want to check that. 14 times, I got the sticky buttons here. No, enter. Oh, the enter button doesn't work. How sad is that? No, apparently no button works. Okay. I really like that other one though. These reminded me of my childhood. The tiny calculators here. 14 times 24. So I get 336 equals, and I have 12 times 21, P. 240 plus 12, 252, P. Now it becomes a one-step equation. Since we're multiplying, we're going to divide. And again, if you've been seeing me and following along with the operation I'll do to both sides, and less than 84 was not anything new for you. We haven't come to that necessarily in our book, but that's not going to be anything new for you guys. And we're going to divide by 252. So we get 1.333 equals P. This calculator it's not as fancy You guys know what that answer is if I required it in a fraction? I'll just put the bar over here too. I mean, if you look at my answer, what is that? It is repeated, but what is 1.3 repeating as a fraction? 1 1/3. 1 1/3? Or 4/3. So these are the answers I would prefer on your test. Everything in the problem was given as a fraction. So we don't want to intermingle a decimal because here's the thing. Some people will just put 1.3. Well, that's different because that's 1 3/10. If they write the bar over the top, then yeah, that's correct as well. But if you understand the concept of the bar and the 0.3 repeating, you probably also know that that's 1/3. And so it's going to be more reliable if you go ahead and convert it to a mixed number or a fraction. It's not wrong here. I'm just telling you this is what I would prefer. I think you're going to make less mistakes this way. Okay? 84, number 22. Oh, okay. So we can't necessarily use my nice pretty shortcut with even numbers of negatives and odd numbers of negatives. We can use it in small chunks, if you will. Okay? The weird thing about these problems and the way the book writes them is that this plus sign is redundant. It's unnecessary. It's already assumed that this is a positive 9 even without the plus sign. But that can be confusing. So I didn't give you any of these on the test. Not like that. What I did give you is something more consistent with this review sheet on number 2, number 3. Number 3. So here's what we're going to do. That's a positive 9. That's the opposite of positive 9. So that becomes negative 9. So I just have negative 9 minus 12 plus 16. I need to simplify some of this. So in this particular chunk or section, I have 3 negatives. 3 is an odd number. Therefore, this is going to simplify to minus 1. Then I'm just going to work it left to right, not necessarily doing addition first, because that's not the rule. When addition and subtraction are present, you have to work them in the order they appear in the problem. So I have 9 ninjas and 12 ninjas. That makes 21 ninjas. 21 ninjas take on 16 pirates. That leaves 5 ninjas. And then 5 ninjas join up with one more in the jungle to have negative 6 ninjas. Or negatives. 6 ninjas. Okay? Sorry, I'm reading this book called Flags of Our Fathers, and it's in like the Battle of Iwo Jima. And pirates and ninjas seemed appropriate. Questions about either of those two or any others that you forgot you wanted to ask about? No? All right, do you guys need some more time to work on the review problems? A few more minutes? Some of you yes, some of you no. Okay, let's take about 7 or 8 more minutes, let you look at them, attempt them. If you're clueless, then skip it. Go ahead and do the ones you know so that we can definitely verify that you know what you're doing, and then we'll clear up any issues you're having, and we'll see if we get to any other review. How much money do you save by shopping at Lowe's? How much money can we save by shopping at Lowe's? According to this problem, I'm not advertising for anybody, but according to this problem, it says the same product costs 17% more at Home Depot. How much money do we save? How much money is that? How much does that end up being? 17%. How do we use that? You can look at, I got to start, and I was like, wait, let me make them tell me how to do it.
Well, don't you have to change 17% to a decimal.
Sure. So what is that? What you did?
Yeah.
How'd you do it?
Calculate.
So what did you get with your calculator?
$185.13.
$185.13.
Well done.
Okay, it's got the same thing. What did you end up doing to get that number? You said you changed 17% to 0.17.
Right. And then multiply it by the original price, or lowest price.
Okay? So what did we multiply by? 0.17?
Yeah.
Yeah? Like that? And you get 185.13. What if the question had been, how much does it cost at Home Depot?
And you say
I would do what?
You would add them together.
I could add that amount to what?
the original.
The original price. Okay. How could I do that in a single step? So the HD price doesn't necessarily equal 185.13, but this would rather be the discount. If I was looking for the Home Depot price, I would do 1089 times 1.17. The significance of the 1 is that's the 100% that's already there, and then I'm adding the 17% that is extra. Okay, does everybody understand what the difference in these two things? This is going to find the sum of these two numbers. I already forgot what it is. Did anybody get that large number? Oops. 1274.13.
Yeah.
Right? Shopping. Math. Okay. Housing market. I think it's not nearly as crazy, or at least people are just maybe people are just used to it. I don't know if you and your family have been in the market for a house in the last few years, but it was a little crazy for a while. Inventory was low, and people were like taking advantage. I think the boss of the company I worked for ended up selling his house for $420,000 after he paid $200,000. So more than double. That's kind of what's happening here. He's probably not going to watch this video, so it doesn't matter. But more than double? Is 300 more than double 120? Yes, Ezra says. Emphatically, his bangs agreed. So, okay. What do you do here? What percent has been added? And I underline that because I thought it was important. What percent has been added? So I'm not asking you 300 is what percent of 120. I'm asking you 300 is what percent having been added to 120. So how do you do that?
Figure out how much money is in between them.
Okay. How much money is in between them? You want to try that?
It's $180,000.
All right, I'm going to just put $180K difference. Is that all right? Now, what do I do with that number?
What I did was I take half of it and put it as a percent.
Half of this?
Yeah,
What do you mean? So 90K?
yeah, as a percent.
What is that?
90%.
So here's what we got to make sure we understand. If this is the difference, this is the amount that has been added, I'm asking you to tell me what is this number as a percent of this number. So you can think of it like this. Your book would word it this way. 180 is, and this is what I see a lot of students write, what percent of 120? Does anybody else do that in this class, or is it just second period? I see there's a couple students who show their work. And that's what I see. And I'm like, oh, instead of a variable, that makes sense. That's essentially a variable. How do we solve that? We're going to divide by 120. And we're going to get this. 1.5 equals what percent? Now, Brantley, let's convert that to a percent. What is 1.5 as a percent? 150%. Now, here's here's where we really need to stop and think. Does this make sense? The first question I asked you was, is 300 more than double 120? Yeah. So to double 120,000, you would add what percent? If you were going to double a number, that is the same thing as adding what percent to it? Adding 100%. Now let's clarify what you just said. When you add 100%, that's the same as taking 200% of it. So we're either going to do plus 100% or we're going to do times 200%. They actually equal the same thing. But it's important to clarify the difference. Now here's how I would do this problem. I would say 300 equals 120 X or P or whatever letter you wanted, right? And then when you divide by 120, you get 2.5. Now what's different? I got 2.5. That's 250%. The difference is the semantics. What did you say? Well, the answer. Wait, what? Are you saying is one of them wrong? Or one of them? What are they saying? The same thing or the same different things? So the question here says what percent has been added? It is 150%. How does this show that 150% has been added? Because it's got the 100% in the 120 that's already there, plus 150% more. Okay? So you'd have to subtract the 100% out of my 250% number, okay, to get, okay, what was added. Okay? So it's 150%. So there's two different ways you can look at it. Just make sure you understand, am I looking for what was added or what was taken of the original amount? All right. What does it mean here to evaluate? What are we supposed to do in like middle school words? Right? If you were telling somebody else in your grade how you did this, maybe you'll be able to tell my camera how to stay up. What do you do to solve these? To find the answers to these? I mean, I'm the one who uses the word evaluate. What do you guys say? Solve it how? Right? Again, pretend I'm a seventh grader. It doesn't have to be that. It's not that far fetched with the way I act sometimes. If I didn't understand the word Jeffrey said, solve, like solve by doing what?
Putting all the numbers in the right place.
Do what?
Put all the numbers in
Okay. Put all the numbers in the right place. Right place meaning
behind their letter.
their letter. Okay, so plug in or substitute the numbers for the letters that they're represented with. Okay? So, again, you've seen me do this before. You might think, you don't really have to do that. No, I know I don't, but I guess I'm trying to be super obvious here. Now, you'll notice I'm trying not to get the sign in. Okay? Not the operation sign, I should say. That's gonna come into play. So everywhere you see an A, we're going to replace it with a -1. I'm going to put it in parentheses to help me see it better. I'm going to do the same thing with the other letters. Okay, and I'll only highlight this one because I feel like you guys are over all the colors. But it's helpful when you're learning it. That also helps us not lose a negative sign because we think, oh, that one's already got subtraction, so doesn't that count for that? No, it does not. You must keep track of all the signs that are already in the expression. So there's a minus, and any negatives that go along with the value of the variable. So this helps me see, well, that's still going to be -1, but the two negatives here are going to combine to make a +4 and then a +5 similarly here. So I'm going to get 8 for A. I'm going to get 8 for A. What about B? 9. 9? Anybody else get 9? That's right. Now, this calculator's not going to be super skilled. Sorry, it's Casio. It'll get you the right answer. You just have to carefully type it in. Okay, but we are going to get 9 for B. What about C? Somebody else. What did you get for letter C? Sorry. Gandalf was talking in my head. If you don't answer these questions, you shall not pass. Too soon. What'd you get, Brantley? For C. What'd you get for letter C? -5. Anybody else get that? Mead and Jeremiah? Huh?
I got positive 5.
You got +5. Finally, a battle, a showdown. Who's right? Let's see. So BC, does that mean something's happening in operation? BC?
Multiplication.
Yes. So I have -4 times -5 on top, and then on the bottom I've got -5 minus -1. So keep track of your negatives, 2 negatives multiplied, you get
Positive.
positive. Good. When the signs agree, that's positive. And then down here, -5 minus -1, that becomes a -5 plus 1, which is -4. The signs here don't agree, and so the answer must be -5. Okay. All right. Good talk. B plus AC, we're going to get 1. Here's how. B is -4 plus, now A is -1, C is -5. So I've got -4 plus, when the signs agree here, we're multiplying or dividing, it's always positive, -4 plus 5. I have more positives than negatives by 1. So my answer is 1. All right. Questions so far before we get to Ryan's fast run? Well, I'll ask you guys, do you think that's fast? 8 miles in 40 minutes? Yeah. What did you use to think when you read that cadence? Why do you think that's fast?
8 miles is a lot.
That's long, but what makes it fast?
It's in 40 minutes.
It's taking them 1 minute.
Is that not a long time for 8 miles?
5 miles.
It's taking it what?
It's 5 minutes.
It takes 5 minutes to run 1 mile.
Yeah, you said 1 minute to run 5 miles.
1 mile in 5 minutes.
That's
Wow,
true.
I can't speak.
That's true. No. I think for that would be really fast, right? 1 minute, 5 miles. How fast is that? 1 minute, 5 miles? Is that faster than you drive, or?
It's like 20 seconds. Well, like 12 seconds. Oh, yeah.
1 mile. 1 minute, 5 miles. 300 miles an hour. That's pretty fast. Okay. Anyways, that's what I was asking you guys to think. Why do you think that's fast? You began to do math in your head about, what is the rate of speed? So let's recap. A unit rate always has a denominator unit of 1. So here's why I have a problem with what Jeffrey said. It was right. It was right. He said 1 mile every
5 minutes.
5 minutes. So if you were talking about pace and cross country, that would be 5 minutes per mile as a unit rate. But is that a speed? Is 5 minutes per mile a speed? It's a pace. It's not a speed. Here's why. Distance is equal to speed times time. So what you gave me was 5 minutes, that's a time, per mile, per distance. That is the inverse of speed. So what we'd have to do, how would we solve for S in this problem? We divide by time. So a speed rate always has to be a distance value divided by a time value, such as miles per hour. But we're looking for it, and I only gave you 8 miles in 40 minutes, so here's what we're going to do. We're going to take that formula, distance equals rate times time, or speed times time, and we're going to say, okay, speed must equal distance divided by time. So the distance was 8 miles. Oops. the time was 40 minutes. What would happen if you divided those numbers? Well, first off, you're going to get a 1 minute here. 1 minute. What is 8 divided by 40? The bigger number's on the bottom. So it's 1/5 of a mile per minute. Or what? Point. I was waiting for the 0.2. 0.2 miles per minute. Now, you might look at that and think, well, that's what he said was actually more useful, 5 minutes per mile. Yeah, I agree. But I was asking for the speed. Okay? So we had to write it miles per minute, or distance over time. If he can maintain this rate for 145 minutes, how far will he run? So, how far?
29 miles.
29 miles. All right, how'd you get that?
145 divided by 5.
Oh, so you took his miles pace that you had from the first one. You used it that way. All right,
Yeah.
good, very good.
That sounds.
What proportion would represent the same problem and get the same answer that Cadence got? So we looked at how do we use proportions to solve rate problems. That was one of the last few lessons. So here's what we're going to do. We're going to put 8 miles in 40 minutes because we're going to do it this way because I think it's actually easier to make a mistake in what KK did. She's right, but she had to do a preliminary step above that wasn't asked of her yet. What we're going to do this way, we're just going to write one ratio and set it equal to a hypothetical ratio where we fill in the value we don't know, 145 minutes, and I'm going to put D question mark. Okay, so again, we can use a proportion to solve the problem, get the same answer that she did, I think. And how would we solve it? We're going to cross multiply. So 8 times 145. So we've got 1160 equals 40 times D, or 40D. Last step there is to divide by 40. Divide by 40. What do you know? 29 miles. Which is a marathon plus a 5K, basically. Or a little bit less than a marathon plus a 5K. Okay, so you have a couple ways to do that. The book lesson that we learned talks about using proportions for that. You can do it another way, as you've seen several students do. I think this is easier, but both methods are certainly valuable. All right, so again, the reason we're able to do this, we're able to set these equal to each other, is because of this phrase in the last question and this one. Maintain this rate, constant rate. That's what allows us to set the ratio, which is a rate, equal to the other ratio. Okay? Now think about that. This speed, because that's what miles over minutes is equal to this speed. That's what miles over minutes still is. Okay? Does that make any sense to people? Speed equals speed because it's constant. So that's why we're setting the fractions equal to each other. Last question. If Ryan runs at this constant rate for half marathon, 13.1 miles, how long will it take him? So here, how could you use, before we do the proportion way, let's talk about what information Jeffrey and KK gave me at the beginning. 5 minutes per mile, is that what you said? 5 minute mile? What would you do with a 5 minute mile and 13.1 miles to find the total? Cole? Okay, so method 1, and this would be, I would actually call this the earlier method. You've done this before. Method 1, you just take your 13.1, and then since each mile is related here, we're going to multiply. That's a word that means multiply. Times 5 minutes. But I'm doing this all wrong. Or at least I'm not showing you why this is incredibly helpful. 13.1 miles, and then I'd multiply by that 5. And that 5 had what units? 5 minutes. Whoops, I can't spell minutes. Per 1 mile. Check it out. I'm using the units here. Have we learned anything about unit conversions? Yes, we have. miles on top and miles on bottom is going to do what?
Cancel.
Cancel out. And so I'd be left with 65.5
Yeah.
minutes, also known as 65 minutes,
30 seconds.
yeah, 30 seconds. Because 0.5 minutes is not 50 seconds, right? Got to think back for a second. Got to take a step back and remember. Now, how do we do that with a proportion? The same way we did the previous problem. Let me see if I have any space to squeeze this in the other way. So I'm going to use the rate that was given in the problem. 8 over 40. I'm going to remind myself it's 8 miles, 40 minutes equals. So what information do we have in problem C? 13.1 miles. So that's on the top. And we don't know the time. So notice I used a different letter there to remind me, hey, I'm looking for time. I want to do the same thing. 8 times t equals 13.1 times 40. 520. 524. Then we're going to divide by 8. And we'll get 65.5. So, is it helpful that I show you two ways to do it? Are you guys just going to do the way you're going to do it? I mean, I'm trying to give you options because the problems might look different than just what you expect. But again, all we're doing is setting one rate equal to the same rate in a different form. Basically, they're equivalent fractions. And the reason I can see and say all of this is because I'm sitting there teaching that to 5th grade. I'm like, oh yeah, that's all we're doing. Scaling up or down the fraction.